Okay. Chapter 2, we dealt with lines. Chapter 3, we dealt with polynomial stuff, right? Now we move on to things called the exponential functions. Before we get started, I want people to, well, I want to cover a couple things which are particularly the exponent rules. So just going to go through them really quick. I'm going to do maybe 1-2 examples, and then I want everybody to try out the problems from below. And I shouldn't have done that because now it erased. Okay, there we go. So the first one that I want to cover, the first rule that I want to cover is this product rule. So if the bases are the same and you have exponents, you can just add the exponents up and then you just keep the same base, okay? The next one, the multiplicative distribution rule. So basically all this means is that your exponent distributes to both as an exponent, you just keep the times with it. Cool. When you have a division, right, you just get to subtract the 2 exponents, assuming that they have the same base. Just as we have for the multiplicative rule, we have an equivalent one for the quotient rule. The bases have to be the same. If you do, you can subtract the exponents. The next one is, so these two are sort of similar distribution rules. Just how in the multiplicative one that you have, so basically the exponent distributes to both or everything that's in the parentheses. The same thing happens with the quotient distributive rule. The exponent distributes to both the top and the bottom of a fraction. So and that's why both of them have the ends on them. Questions yet?
No.
Yes. Okay. These are a little bit easier to handle. The powers rule. So if you have an exponent to an exponent, you can multiply the exponents. Cool. I don't think the next 3, well, the next one we won't use too much, but it's worth mentioning it anyway. You can turn any fractional exponent. So let's say you have a fraction as an exponent. You can turn it into a radical, and then that you can plug into your calculator if you need to. This one we won't use too often, but it's worth mentioning it anyway. The next one, though, this one, the negative powers rule. This one's the one that we're going to be using very repeatedly today. Specifically, it deals with that negative. If you have that negative there, then that means you can do this to it, 1 over the positive of it. So this one this one's actually going to show up a lot, specifically because we're about to do some graphing with it. And then the very last one, this is just to round out the rules. Anything to the 0 power is 1. Just anything. It doesn't matter what your A is at all. Anything to the 0 power is always equal to 1. Cool?
Cool.
Okay. So what I want to do, I want to sort of start using some of these to do a couple of examples, right? Does everybody see the examples?
Mm-hmm.
Okay. So these are going to be some examples I'm going to work out just so that you guys can see what the heck's going on. Cool? So I'm going to start with this first one right here. This is a fractional exponent that's on the outside. So I'm going to use the, which one is it? The distributive one. It's going to everything inside the parentheses. Does that make sense? So I'm going to have something that looks like negative 8 to the 2/3 times b to the 6th to the 2/3 times c to the 12th to 2/3. Does everybody see what I did?
Yeah.
Okay. I am going to overly explain this. Does that make sense? So if you guys want to skip steps, that's perfectly fine. If you don't, that's perfectly fine as well. I'm just doing it so that everybody can understand what the steps, what I'm doing for each one of the steps. Does that make sense?
Mm-hmm.
All right. So okay. So everybody see what I did, right? I distributed that 2/3. This, whoa. Come on, there we go. And what are you doing? Okay. This, I'm gonna just keep as it is. Does that make sense? So 8 to the 2/3, I'm not gonna touch it for now. What I am gonna do is I'm gonna try to simplify this thing. So this has an exponent to an exponent. So that means I can multiply the exponents and keep the base the same. So b is going to be 6/1 times 2/3. And then same thing with the c. I'm going to have c to the 12/1 times 2/3. So I'm using the, let me see if it pops up. I'm using the powers rule, this one right here. Got it? Now I'm going to clean this up a little bit more. So equals, forgot to put the equals, 8 2/3. So now I want to do just this separately. So 6/1 times 2/3 is equivalent to what?
4.
4.
Yep. So I'm going to do it over here. So 6/1 times 2/3. This is 12 divided by 3. Multiply straight across.
4.
And this is 4. So this now becomes b to the 4th times c, and what's going to be this thing? So 12/1 times 2/3 is
24.
8.
right. 2/3 is going to be 24/3, which is my 8. Got it?
It's not that bad. It's not bad at all.
Not that bad. Not that bad at all.
It's a little confusing at first, but once you do the math, it makes sense.
Right. So the idea here is all of these things over here. So both these lists, these are just rules. You can use them. You can invoke them as you wish. Cool. So the last thing we have is 8 to the 2/3. This is one of the ones where we're going to be able to use that fractional exponent. So this one right here. And we're going to use it to hopefully make it a little neater. My thing, there we go. So now, 8 to the 2/3 is equivalent, if we use the rule, the cube root of 8 squared. What's 8 squared?
64.
Right. It's going to be the cube root of 64.
Wait, which
And,
rule?
huh?
Which rule is that one?
That is the fractional exponents rule. So let me go back to the, my thing's got to be a little faster. Come on. Come on. There we go. Okay. It's that blue one.
You're just reversing bit, basically.
Right. I'm reversing it. I have this side and I'm turning it, or sorry. Yeah. I have this side. I'm turning it into this side.
Okay.
Got it?
Mm-hmm.
So these can go in both directions. You can have the left side turned it into the right side. You can have the right side turned it into the left side, which way you want. And then the last step right here, the cube root of 64 is actually 4. Because if you take 4 times 4 times 4, you get 64.
Wow.
Right? So then now we have this going on. Now I'm going to go ahead and this negative, do the parentheses mean anything with this negative that's up front here?
You got to distribute the negative.
Yeah, I mean, but all of these are multiplications, so it just makes the whole thing negative. Does that make sense?
So it's already negative, so don't even worry about it.
Yeah, exactly. So you're going to have now negative 4, and then these two things, we've already done them, right? B to the 4th, C to the 8th, and we are done.
Bam.
How much of a lag is there? I guess I can't tell because I'm not.
Doesn't seem that bad. I feel like it seems fine.
Okay. You guys got to let me know if there's any lag. I don't know how, well, I don't know if there's anything I'll be able to do about the lag, but I mean, there's a couple of things I can maybe.
Seems to be like your everything's in real time. I don't see much
Okay.
lag on my end, at least.
So what I'm going to do, I mean, maybe the only other thing I can do, I'm going to turn off my video. Let's see if that works. I know you guys probably enjoy looking at me on the bridge of the Enterprise, but I think we can forego that if needed. Okay, any questions at all?
I think someone mentioned, can you do it again, because they didn't see it because their laptop just for some reason didn't show it.
Oh, issue with the laptop. Okay.
You could
I think
probably
I
run
can.
through. You could probably run through just the work if you probably want, and just kind of explain
Yeah.
how to do it.
So let me.
See what the chat says.
Yeah, I didn't have the chat open, so that was my bad.
Yeah, it says, "Can you do it again, please? I had an issue with the laptop. Just explain again."
Just explain again. Yeah. So it seems like you guys can see the chat too. So if it looks like just now, I didn't have the chat open. So it's me erasing stuff. I didn't have the chat open. So if you guys notice that there's a chat box going off and it looks like I don't see it, just let me know.
No problem.
Okay. All right. So from here, that is a fractional exponent. So we get to use the this. No, wait. Sorry.
Your mic is lagging a little bit.
Yeah.
Really? Okay.
It sounds good. It sounds perfect again.
Okay. So I wonder if it's it. Oh, you know what it might be? I'm on a wireless headphone. You know the ones from your
AirPods?
yeah, well, not AirPods, but these wireless ones, the Bluetooth ones, and it has a
Oh.
microphone. I think it might be coming off of the microphone. So if it happens on a regular basis, I have a second set just in case. So just let me know.
Perfect.
Cool. Okay. So from the very beginning, from right here, we get to use the distributive multiplicative rule. So it's this one. So it's an exponent to a bunch of stuff, right? And they're all multiplications in between. So I can go ahead and distribute that exponent over everything, okay? That gets us to here. From here, notice how I wrote them. I wrote them in a particular manner so that we can use the powers rule, which is right there in green. Sort of an exponent to an exponent, we can multiply the exponents and keep the base. So that's where this math came from, where we have 6 over 1 times 2 over 3. And then over here, for the C, we have 12 over 1 times 2 over 3. So then that's where this math came from. And it just so happens I did them over there to the right-hand side. And that's where we get our 4. That's where we get our 8. The last thing that we hadn't done after there is we have this 8 to the 2/3. This is where we use our fractional powers rule. So if we have an exponent that's a fraction, we can turn it into stuff that has a square root on it. Okay? That work is all right here. Some of this you might need to do with a calculator, but you got to start getting comfortable with not doing it with a calculator. So 8 squared, I think somebody in here, I think it was Libby said it was 64, she was right. And then you take the cube root of it, and that is 4. So and if you round it out, you get this right here. Mashal, we good? So I'm recording this as well. This thing.
Oh, you can look back at the lecture?
Yeah, so I'm recording this as well. So you can look back at it and notice that I'm doing this on the notes that that we were doing in class anyway. So you guys get the final product.
Perfect.
So
That is a
I'll put-
feature I like.
yeah. Hell, this might even start me doing that stuff. But we'll see. All right, so I want you guys to go through as many of these as possible, and I'll answer some questions as we go.
Are we solving them or just saying what rule it is?
Huh?
Are we solving it or just putting what rule it is?
Solve it out. Try to reduce it down to
Okay.
as little exponents as possible. How about we say that?
Okay. You want us to do all of them?
Huh?
You want us to do all of them?
How about this? I'll give you guys maybe 10 minutes with it.
Okay.
Whatever you can get through in 10 minutes.
Perfect.
If you want to aim for some trouble spots and skip some of the simple ones, go ahead, and then I'll cover a couple of the harder ones.
Okay.
I can see why people want to come to school now. I can see.
On the first, in the first row or the first and the second ones, are those the same, like the same, you're doing the same thing?
Yep.
Or does the parentheses change it?
The parentheses do change it.
Wait, so how does it change it?
So how about I do that very, very, very first one?
Well, if you change that 4 to a 5, it'd be a negative.
Exactly. So,
But since you have a positive 4, it's going to be a negative times a negative times a negative times a negative, which make it a positive.
you're talking about the first two,
Yeah.
correct? Yeah. So let me do this one really quick. So this 4, whoa. This 4, does it hit the negative or does it not hit the negative?
What do you mean?
No.
Like,
No, it doesn't.
Right, so it doesn't, it only hits the 3. Hence the reason why parentheses are very important. So in the one next to it, the 4, the exponent, does actually hit the negative this time.
so
make
for
sense?
the first one, you just do the 3 times 3 times 3 times 3 and make the answer a negative?
Exactly.
Okay.
So then this one would be negative, like you said, 3 times 3 times 3 times 3, right? And
You
that is a
get that
negative,
answer.
right? And that's going to be negative 81,
Oh, okay.
right?
I got it right.
Yay.
But for this one, this is telling me to do what?
Make all of them negative. So negative 3 times negative 3 times negative 3 times negative 3.
Right, negative 3 times negative 3 times negative 3 times negative 3.
Which is
All of
equal
these
to-
multiplied, right? My final answer is going to be what? Positive or negative?
For the
Positive.
second one?
It's gonna be positive.
Right, this is going to be positive because you have a negative times a negative that makes it positive times another negative, make it negative, another negative makes it positive. So our final answer now is going to be 81.
81.
Got it?
Yes, sir.
All right.
The next one's 8x to the 0 power.
So it's just 8, right?
Yeah.
Or is it just
TV's not working.
Would the 2/3 2 one be 64?
Which one?
The one under the negative 3, 4. Like the one under the first one.
The one under the first one. This one.
Mm-hmm.
And what'd you say it was?
64.
Yep.
Yay!
So did you first did you you got 12 and then Sacha, what did you do for that? You said what
So-
was the answer?
I got
So this-
64.
Right,
I
this one's
just
going to
did-
be,
Yeah.
go ahead, Bryce.
I just did 2/3, so I did 2 times 2 times 2, which was 8, and then I did 8 squared, which was 64.
Oh, perfect.
That works.
So
That
it's just
works.
super simple.
Yeah.
Mhm.
So this 2/3 is 8, which is squared, 64.
Perfect.
Okay. The other way, we have exponents here, right? We have an exponent to an exponent. We can multiply them. So it's going to be now 2 to the 2 times 3, 2 to the 6th, 2 times 2 times 2, 4, 5, 6. So 2 times 2 is 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64. Any which way you want to do it works out.
Perfect.
Let's see.
Perfect.
How would
So-
you do something that's like 2 to the 3 over 2?
So something like this one.
Yeah.
This one's going to be a little wonky, but all I want you guys to do is use the rules for them.
So it'd be a square.
So I'm going to
Would be
first of all.
quotient distribute rule? No, actually no.
So this one's the one where you have a fractional power and you turn it into whatever root you need.
So it'd be 2 cubed squared.
Right. So this is going to be a 2 outside, then 2 cubed. Right.
Whoops, my bad. I got it flipped.
And what's 2 cubed?
8?
8. So this is just going to be the square root of 8. That's it.
Okay.
Because there is no square root of 8, we can leave it as it is.
So what happened to the 2?
Huh?
Yeah.
Oh, what happened to the 2?
Hmm.
So whenever we have a 2, so we
I get it.
put a 2 there just because of the rule.
Right.
Whenever we talk about a square root, right, we always assume that there's a 2 there.
Okay.
Does that make sense?
That's good.
We just
Yeah,
don't write it. We write it for anything else. So if we want a cube root or a 4th root or an 8th root, then this 2 right here changes.
So the top goes in and the bottom goes out.
Yep. Got
I
it?
believe someone asked to go to the bathroom as well.
Make sure you take a hall pass.
We'll be monitoring the hallways to make sure nobody
Yeah,
has
yeah, exactly.
virus.
We'll be monitoring the hallways. Please don't take your tablet in there with you and have the audio on.
Fucking the camera pops on.
Yeah,
Doesn't know it's on.
right?
Honestly, that'd be the worst. Honestly, that'd be so
That would be-
embarrassing.
Yeah.
No, Chewy! Chewy got captured.
No.
You're in the bathroom seat looking terrible as hell because you just woke up. Everybody, there's fucking 15 people in here looking at you.
Looking at you, yeah. That would be horrible.
See, if
But
she
what-
wasn't nosy, Chewy wouldn't have got captured.
Huh?
If she wasn't nosy, Chewy would never got captured and never got out of there.
Star Wars.
Oh, and Star Wars? How about
Sorry.
this? Let's see, hold on.
Can you go to the 7/11 and then 7/13? That's a long
No.
number.
So, since people are watching Star Wars,
There you go. You gotta show me how to do that.
I don't know if you were allowed to do it, or I don't know if you can. Actually, you might.
I just
If
gotta
you
go to
go-
the settings in Zoom.
Yeah, if you go where you should have like a little tab at the bottom where it has like a microphone and a camera and some other stuff. If you go to the arrow right next to,
Oh, choose
camera?
virtual background. I got
yeah,
it.
choose virtual background.
I gotta download some.
Yeah, you get to download them. No kid, like no joke. I took maybe a couple minutes, maybe about an hour. May or may not have taken an hour to find a couple good backgrounds to use. How far down are people?
I'm on the
I'm on the
third-
2a
third row.
squared 4ab squared one.
2a squared 4ab. Aha, okay.
Are you foiling that one?
Huh?
Do we foil for that one?
Yes and no. Not exactly foiling. What we're going to be doing is grouping stuff together.
Hmm.
So how about this?
Oh my God.
I will, let me minimize that. Let me do this one first. 7 to the 11th
Yeah.
over 7 to the 13th. So what rule do I use for this one?
Is that the quotient rule?
But that one's the quotient rule. It's going to be what over what in this case? Oh, what minus
11.
what?
11
minus
minus
13.
13.
Right, this is going to be 7 to the 11 minus 13. So 11 minus 13 is
Negative 2.
2.
7 to the negative 2.
So you're just subtracting the powers or the not the powers.
Yep.
The fucking,
Yep,
Just those.
right.
And it'd be a
So-
negative 2 as well since 13 is negative 13.
So when you do this subtraction right here, right, That's what gets you that -2.
Okay, so 11 minus 13 equals -2. Perfect.
Right. So now 7 to the -2 is what?
7 to the -2 is -49. Actually, it'd be just
One.
49. Positive.
Wouldn't it be 1/7 to the 2?
Right. So
1 over
here's
7
where we
squared.
use that negative powers rule. So this automatically becomes 1 over the positive of the thing that we had.
Oh,
Got it?
Tricky. Okay, I see.
I know. I know.
so it'll equal 1 over 49.
Exactly. 1 over 49. Fancy way of saying 1 over 49.
Well, that's bullshit.
I can dig it.
The fancy way.
Yeah. So actually, this one's the more useful one that we're going to be using a fair amount today. This rule right here. Because it'll go ahead and explain a fair amount of stuff when we get to graphing. And let's do one more. It seems like people were a little concerned about this one. Well, people were trying to do this one. They're like, what do I do? Yeah? Okay. It looks like you have to distribute, but you don't. So you have multiplications in between here, correct?
Mhm.
Okay. So what we're going to do is we're going to group stuff together. So in multiplication, let me do this on the side. 3 times 5 times 7. Well, let me do 2 times 3 times 5. What is that?
30?
Right. It's going to be 6 times 5, which is 30, right? Make sense? And it doesn't matter how we organize the numbers. So I can do 5 times 2 times 3. Notice that it's still the same 3 numbers, multiplied them, right? 10 times 3, 30. Does that make sense?
No.
No.
Yeah. So in multiplication, you can switch the order.
So where did you get 2 times 3 times 5?
Right. Does that make sense? It's the same
Yeah.
3 numbers, but I can rotate them and spin them around however I want. I'm still getting the same result at the very end. I'm still getting that 30.
Wait, where'd you get the 2 times 3 times 5?
Oh, this is just a separate example.
Oh.
Yeah.
Oh, okay.
Same
that was
result.
confusing the fuck
Yeah,
out.
it's to push the idea that for multiplication, you can, so long as it's within a multiplication, you can reorder them however you wish.
Okay.
Does that make sense? So like I said, it's the same 3 numbers over here, right? In different orders, but I get the same result at the very end. Got it? So to use that on this example, we have numbers, right? Then we have things that have A on them, right? And then we have things that have B with them, right? So we are going to group according to the grouping that we just sort of figured out. So it's going to be the 2 times 4. Those are just the straight out numbers, right? And now we're going to group the A's, which are, in the first one, we have an A squared times an A from the second one. And then in the third one, we have a B times a B squared from the second one. Does that make sense?
Yeah.
So where'd you get the 2 times 4 from?
So how about we do this? So the 2, the A squared, and the B come from that first one, right? And then the 4, the A, and the B squared come from that second one.
Oh, so you got the 2 numbers, obviously. Oh, so it's just all common factors, basically, or all.
Yeah,
like,
exactly. Yep, I'm grouping together whatever's common.
Perfect.
Yeah. So then now, 2 times 4
8.
times this thing right here. A squared times A.
2a squared.
A cubed.
A
Yeah.
cubed. Cool.
Mm.
And then B times B squared.
B cubed.
B cubed. And we are done.
Perfect.
Cool.
Mm-hmm.
No big dealio, right?
Nope.
Okay. Kinda.
Yeah.
All right. I don't want to do the rest of these because I think we're gonna get bogged down with too much of the rules when I really want to get you guys into the graphing, which is something that I know you guys can do already.
No problem.
Okay.
So specifically, what we're gonna, like I said before, right? We're gonna be covering what's called exponential functions. The very first chapter was just like handling transformations and graphing in general. The second chapter was doing lines. The third chapter was figuring out stuff for polynomials and how they graph. Now we get to move on to exponential functions and what the hell they do. So specifically, I have this picture that we have right here, which sort of rounds out what we're going to be doing for the next couple of weeks now. Let me see. All right, so we have two functions here. We have a 2 to the x, which is what we call an exponential function in this case, and then we have the good old regular 2x. F of x is the one that gives exponential growth. And g of x is what gives linear growth. So the difference is for g of x, right? The thing that sets both of these two things apart, exponential and linear growth, is how they grow itself. So g of x, let me actually make it so it's a little clear. I don't run over so many lines. G of x has a constant rate of change. So it is increasing by a fixed amount every time. Does that make sense? And hence the reason why we have the thing called the slope, right? So we know that for linear growth, there we go. The heck is it doing? There we go. It goes up to over 1. You guys see that? It goes up to over 1. Up to over 1. That's what defines our linear growth, okay? And f of x is a constant percent change. So we haven't gotten to this completely yet. We'll get to it in a little bit. So the manner in which this graph changes.
Is that your dog?
Is that
Is
a
my
dog?
dog snoring?
I think so.
Oh, I didn't know you guys could hear her.
That's funny. So the manner in which the exponential graph grows is better defined by some percent that it is growing compared to the previous x value. Does that make sense? So to show that off, I've got two tables here. So notice that these, right, they still grow in the same manner, but depending on which one of these you look at, they grow very differently, right? So the 2 to the x, it's going up by 2 for every 1x. Does that make sense?
Yeah.
When on the other hand, when you look at the 2 to the x, if you grab this one, multiply it by 2, you get that. If you grab the 2, multiply it by 2, get the next one. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. And so on and so forth. Does that make sense?
Yeah.
So, sort of the same idea, right? As we bounce on the linear, we add a specific amount, right? But for the exponential, as we go down, we multiply by a specific amount. In this case, we were multiplying by 2, because that is what the function was telling us to do. Cool? Okay. Let's summarize a couple things for them. What does it look like my domain would be?
For fx, or
Yeah, for fx.
from 1 to 64.
So, sorry, for that function, for
2 of x.
for 2 to the x, what's going to be that domain? So what are the two things that we need to check for a domain? We can't do two things, right?
You can't divide by 0 or have a negative. What is it? Have a
In
negative.
a square root.
In a square root, right? Does it look like we're going to do either one of those?
No.
Nope. So we have nothing to check, which means my domain will be
negative infinity to positive infinity.
Negative infinity, right, to positive infinity. And that makes sense, because if you look at the graph, the green one, let me get rid of all the other lines here. So if you look at that green one, this one, right? Technically, this keeps going this way, and it keeps going that way. Cool? What's the range in this case?
Wouldn't it be the same?
No, it's 0 to infinity.
Yep. It'd be 0 to infinity. So it turns out that, you guys remember the asymptotes? Your graph, so the graph for this, for f of x equals 2 to the x, it just keeps going that way. And it gets really, really close to the that x-axis, but it never crosses it, so it just keeps whoosh. It can never drop down below that. It can never drop down, at least this function will not drop down below 0. So we have come on, there we go. We have our range. So as f of x goes to negative infinity, what y values am I getting closer to?
Positive infinity. Negative infinity.
So take a look at the graph for it.
0.
Right.
0.
So notice that's this thing. It's getting smaller and smaller, but it's never going to cross that 0 axis. So this is going to approach 0. As x approaches positive infinity, what's happening to my y values?
It's going to infinity.
This is also going to infinity. Does that make sense? So up here, right? Notice what's going on. Whoosh, goes up that way. Okay. Your f of x's, Does it ever look like they're going to be negative?
No. So it's always
Nothing.
positive.
Right. So your graph for f of x never shows up down here. Whoa.
So it's always positive.
Right. It is always positive. It'll never show up down here, ever. At least this version of it. Does it ever look like it's going to cross the x-axis?
No.
Nope.
No,
No
just the
zeros.
border of it.
Right. It's always going to, this thing, right? It's going to be asymptotic the whole time. It'll get closer and closer to 0, but it'll never touch it. Got it? The horizontal asymptote will be what?
0.
Yep. And then the y-intercept, this one's a pretty nifty one. That point is 0, 1. So this graph, and it doesn't matter what you graph, it can be b to the x, whatever b is, it doesn't matter. It will always cross through this point right there, through that point 0, 1. Got it? Okay. All of the things above are what we're going to use for functions that look like this. These are the most easiest sort of to handle. So we're going to see a couple of these right now. Functions a times b to the x, where a and b are non-zero numbers. Okay. The a is what we call the y-intercept, or if you look in for a word problem, let me write that down. Is going to be your initial value. So depending on what you're talking about, something in the word problem is going to give you maybe some sort of inkling toward an initial amount of something, so an initial population or an initial sample of spores or whatever, right? That is going to be your initial value. And that just so happens to be that y-intercept. So that point that comes from up here, okay? And your b is what's called the growth or decay factor.
Oh, I remember this.
Huh?
I remember this.
All right. Okay. Specifically, for a growth, you have that b is equal to 1 plus whatever percent change. And then for a decay, it'd be the b is equal to 1 minus the percent change. So somewhere in the problem, when you see problems like this, somewhere in the problem, it'll tell you it's growing by 5%, or it's leaving the body at 2%. Does that make sense? So that percent change, right, for the first one will be 5%. It's increasing by 5%. And then in the second case, it'd be decaying. It's changing by it's dropping by 2%. Make sense? So those are the things that you have to sort of pick out from the problem. You put them into this thing and you get your a times b to the x. You get an easy function that way. Cool?
Yeah.
Okay. So let's start with, I'm actually going to skip example 2. I want to go to just getting you guys to evaluate some stuff. Let's move on to example 3. So function notation still works the same as it did before. So how would we evaluate f of 2? What does that tell me to do?
Plug the x,
Wait.
And what do I do with it?
and then you solve out the whole equation.
Right, so f of 2 does that make sense? So notice nothing different happened. The same stuff that we were doing before is what was happening here.
You're just plugging 2 in the x.
Yep. Nothing fancy. So then,
And the same thing for f negative 2.
right, exactly. F3, this is going to be to the third, so 27, so 5. What's 27 times 530 minus?
Wouldn't that be like 135 or something?
I don't know, something.
I got a calculator. I'll do right now.
135.
115.
Is it 115?
Yeah.
I got 135.
Okay,
135.
or 135?
Yeah.
All right. 3, negative 2 plus 1, 5 to the 3 of 5 times 3 to the negative 1. And this is equal to what?
Would it be
5 times 1/3.
Yep. So 5 times this thing right here, we get to use our negative exponent rule, right? So it's going to be 1 over 3 to the 1. It's equivalent to 1/3. 5 over 3, and we are done.
got that?
Got it?
Yes, sir.
Okay. So the fourth example has us doing a little bit more with a times b to the t. So this stuff right here. This stuff right here. Cool. So let me refresh really quick.
Dang.
A is our y-intercept, or our initial value. And our b is our growth or decay factor, depending on which one we need. A growth is 1 plus a percent change, and the decay would be 1 minus that percent change. Got it? So in this question, we're talking about a population for the country of India, right? It's about 1.25 billion with an annual growth rate of 1.2%. In this case, I give you the formula. Let's go ahead and try to derive it. So what's supposed to be the, so we have f of x, a times b to the x, right? What's my initial amount that we're talking about?
1.25 billion.
Right, so we're given this as an initial amount. We're gonna assume that our count of years starts in the year 2013. Does that make sense? And our growth rate is what?
1.2%.
It's gonna be that 1.2%, correct? So now, how do we get our B? That is something that's not completely spelled out. It's a growth rate. Does that make sense? So 1.2%, what is that in a decimal?
.012.
Right, this is where we do the 0.012, correct? And since we have a growth, what do we do?
1%, add a percent.
Right, so we're going to do, well, we add 1.
Yeah.
So our formula is 1 plus percent change, right? This is the percent change that we need to plug into here. So then that is going to be 1 plus 0.012, 1.012. So we've got everything, right? We got our initial amount, which is the 1.25 billion, times our B, which is this thing. Whoops, 0.12 to the x. And we have our function, right? Notice that that function is exactly what was given to us at the beginning. We good?
Yeah.
All right. We haven't answered the question yet.
Yes, sir.
According to the model, I know. According to the model, what will be the population of India in 2031?
That's how many years?
So 18 years.
So how'd you get that?
231 minus.
31 minus 13.
Right.
So 18 years.
So it's 18 years from 2013, right? So it's
Right.
this thing right here. This is the thing that we want to actually plug in. So f of 18 is 1.25 times 1.012 to the 18th power. Have I lost people yet?
Yeah.
Real far or meh?
I said not yet.
Oh, not yet, okay. I need to bring a calculator next time. I forgot mine in my office. And now I don't have a button for no. Definitely need a calculator for next time.
Yeah, I forgot. Well, mine's like across the room from me, but it's just too far to get up and get it.
How far do you want to round the decimal?
I would say 2 is healthy.
So 1.24?
Yep.
Right.
I think that's healthy enough. I'm actually going to use my cell phone for this one. To the 18 is that.
1.55.
Yeah.
So
1.55.
1.55 about.
Yeah.
1.55 what?
Billion.
Right.
Billion.
In 2031, the
The population.
Right, population. Maybe I should write them out, huh?
Oh, is this where you have to write a damn essay for your answer? I remember this now.
We haven't been gone that long. And it's not too, it's not a big essay. 0.55 billion.
I'm just glad I actually know what's going on.
Yes! That makes me feel good. That makes me feel good. So how are we dealing with this stuff?
I have no idea, so now you feel bad.
Darn it.
Don't feel bad. I had to retake pre-calculus.
Yeah. I-N-D. Okay. How do people feel with this stuff? Not bad?
Easy. Easy.
Okay.
I feel great when you don't give us bare minimum.
Yeah. That's true. I should write out the whole entire thing.
No, when the questions are just you get like bare minimum,
Oh, yeah.
and you got to figure it all out.
Right. Okay, so the next example, we sort of have to semi-work backwards.
Yeah.
In 2008, what does it say? 11.63 million iPhones sold in the world. By 2012, 125.05 sold, million sold. They grow exponentially, right? We want to find, hold on, okay, yeah. We want to find a exponential function that sort of calculates this pretty well. Now, I give you guys values here, but it's really hard to, so this is something that you'll learn in statistics. There's this thing called exponential regression. We'll get to it, well, you guys will get to it later. I'm gonna give you guys the basis for how to find the growth rate. Does that make sense? So looking at the information, we can automatically say A is equal to something. What is that something?
A is equal to, is it 11.63 million?
You can say that one. I'm gonna go ahead, so how about this? We'll go ahead and use that one. Some people might have been thinking this, and since we are sort of, the function that we're gonna get out of this is gonna be an approximation. It's not gonna be an exact thing, but the theory is still all there. Does that make sense? So if you make A either the 11.63 or the 1.39, which is the very beginning of the graph, right? Either of those work out. So if you take a look at how this thing grows, does everybody see my green pen?
Yeah.
My red pen? You guys see how this is like sort of increasing there?
Isn't that skewed to the left or something like that?
Yeah, but we're not gonna do, so you're thinking about stats. We're not gonna do stats right now.
Oh, well, you said stats. Sorry.
So,
Hey,
yeah,
calm
I
down.
know.
Calm down.
Yeah, I know, calm down. Learning two subjects at once. So the actual way, let me put it this way. The legit way, the most accurate way to do this is by using statistics. We're not gonna use the statistics here. Just gonna learn the stuff, we're gonna use the stuff that we've already learned just up to now, okay? And the big problem is this. We don't know what B is. Like we have no clue. Nothing's given to us. So we have to sort of reverse engineer our value for B. Cool? So the easiest way to do that is we are going to grab, let me get rid of my lines here. We are gonna grab pairs.
I'm stuck.
We're gonna grab pairs and divide them. So we're gonna grab this one divided by this one, right? Or we're gonna grab this one and divide it by this one. Or this one, whoa, big pen. Or this one divided by the previous one. You guys see what I'm doing? I'm grabbing one value and dividing it by the next one. See how much that one is growing over a year. Does that make sense? So between these two, my thing is lagging now. Between these two, right, I'm gonna do 11.63 divided by 1.39. I get 8.36.
Wouldn't that be 8.37? Or are you not rounding?
You are correct. Okay, this one is a pretty drastic increase. Let's go ahead and do a couple of the other ones. In 2009.
$1.93.
Oh, 1.78.
Let me try.
What did you do?
20.3 divided by 20 point, oh wait, whoops, 11.63. I got 1.78. Let's go ahead and do the next one. 39.99 over 20.73.
1.93.
1.93.
Yeah.
Let's try the next two. $72.29 divided by
1.81.
1.8.
Yeah, 1.81.
Yeah, 1.81. So 72.29 divided by 39.99. 1.81. Let's do one more for kicks and giggles.
Are you gonna add these up and take the average, or?
No. We're gonna sort of guesstimate. I know that's probably not a word you guys want to hear, but for now. So here we have 125.05 divided by 72.29.
1.73.
1.73, right. Okay, we did a healthy number here, right? So notice the, come on. Don't you love when you choose something and it doesn't do it? Still doesn't want to do it.
It's almost like being married.
Wow.
It's supposed to be negative?
No, it's almost like being married.
Oh.
Doesn't want to
Okay. Delayed chuckle. So if you guys notice that first one is sort of the oddball.
Yeah.
Right? The other ones actually float around the right amount. You guys see that?
So if you keep on going.
Right. So if we keep on going, we should expect this to still float around the what, 1.8?
And not exceed 2, right?
And not exceed 2, right? It doesn't seem like it'll exceed 2. Does that make sense? So we have our answer for our B. Well, at least we have an educated guess for our B. We're going to go ahead and say it's about 1.8. Does that make sense? So just using these right here, we get our educated guess of about 1.8. You guys got it?
Yeah.
So at the very end, we have our initial, right? The two initials that we're able to use here, it doesn't matter which one for this case, since this is all an estimation. So our N of T, the number of iPhones, right, is going to be my A. I'm going to go ahead and use the 11.63, just because that's the initial that's been given from the problem. Like I said, you can use the other one. times 1.8 to the t.
I thought you had a.
And we are done.
Didn't you have to add a percent? So it's because it's growth.
So that's if I give you a percent.
Oh, okay, yeah.
Right?
Yeah.
So in this case, we sort of reversed engineered it, right?
Yeah, I got it.
So let me ask you guys this. Do we have a growth or a decay?
We have a growth.
Can you tell me of what percent?
I thought you were going to tell me.
Eventually. Before we leave today, I will tell you.
So we take that 1.8 and turn it. Fuck.
Keep going, keep going.
Move the decimal place over and then add a 1?
In essence, yeah.
Or you want to turn it into percent. So to take the decimal to turn it into percent, right?
Right. So
you want to move it closer to the 0?
We know our B is 1 plus some percent change, correct? Since it's a growth. And we just sort of guesstimated that that B is going to be around 1.8. Does that make sense?
Yeah.
This tells us that our percent change is about 0.8, which is what percent?
0.8%. Or you want to go the other way, right?
Right, so this is in a decimal, change it to a percent. How do we do that?
That's 80%.
That is 80%. So we need to do the move it over by 2. So 1, 2, right? So then, whoops, 80%.
I have a question for you.
Mm-hmm.
So if this kind of a question was on a test, would it be okay if we just solved out B algebraically, or do you want to see this educated guess kind of work with the graph over a period of time?
I would say the funky way that if I want this is sort of, how about this? If I expect an estimation, I will say estimate the equation for blah, 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 blah. Does that make sense? In which case, a process like this would be fine, right? But whenever I say, give me the equation for blah, 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 then you have to give me the exact numbers. Does that make sense?
Yeah, I mean, I did it algebraically, and it came out to B equals 1.81. So your educated guess was like really
Not
close.
too far off.
If you solved.
Right. So if I ask you guys for an educated guess, so long as it's not too far off and I see your logic behind it, you'll get the full credit.
Nice.
You just got rid of that 1, right? And made change to 0.8.
Practically, yeah. So the quick way to do it, like you just sort of found out, right, is if you look at the equation itself, whatever is not with the 1, so that 0.8, that's going to be your percent. So it's 0.8 as a decimal, which is the 80% as a percent. You have everything you need.
Okay.
Got it?
Okay.
Okay. These are So the real, you guys are going to get a semi-quick lesson in finance.
Quick lesson.
Quick lesson. For those of you who have credit cards, applying compound interest. Okay. This is actually how credit cards compound your interest. So the P, technically this equation, come on. This equation is an A times B to the X, right? It's just a spicy one, that's it. So the P is your initial amount, whatever that is, right? There's the P. The R is whatever rate. The N is how many times you compound it in a year. So there's 2 times that the N shows up. And then the T is your variable.
Oh,
At this point, this is all just plug and chug. So invest $3,000 in an investment account paying 3% interest compounded quarterly. What is the equation that models the investment account and how much will we have in 10 years? Plug and chug. A of T. How about actually we, what's P, what's R, and what's N?
Isn't P 3000?
The 3 is the, yeah, 3,000
R be the 3%.
is the 3%.
And
What is
the
this as a
N would be,
decimal?
wouldn't it be 0.03 or
Yep.
003?
Yep.
03.
0.3. And N is compounded quarterly.
10, maybe 10 years?
4.
4. So N is 4. So this N comes from compounded quarterly. It happens 4 times a year.
I didn't know that, actually.
Well, now you know.
I'm just too young, probably.
No. You haven't heard it enough. Turn on the news, and you'll hear when they do the financial reports. But
Yeah, quarter.
This is the important part of any business, giving quarterly reports.
See if you made money or not, huh?
Because there's 4 quarters in a football game.
There's 4 quarters in a football game. There's 4 quarters in a dollar. What else is there?
Yeah.
So now we find our equation, A to the T. Tell me what to write.
3,000.
3,000.
1 plus 0.03 over 4.
Times
4 times T. 4 times,
yeah, 4 times T. 3,000. 1 plus, what is 0.03 divided by 4?
So that'd be 1.03 divided by 4?
Yeah, I'm trying to find a decimal value for it. 0.0075 to the 4t.
And we solve for T?
Well, hold on. Let me, 1.0075 to the 4t. So this gives us our equation.
Oh, and then
Now we get to do the 4 years. What does that tell me to do?
put the 4 where the T's at.
Not 4.
10.
10. There we go. So we need to find this, right? A of 10.
A of 10. And then you get your essay answer.
Yeah. 1.0075 to the 4 times 10. And now I need a calculator because I don't know. Oh, I have one here. Okay.
4,045 and 5 cents.
That times, I think you might be right.
Of course I'm right.
Oh, well, look at you.
The confidence.
4,045. .05. So notice, look what happened. This is the power of compound interest. If you have the, and this is highly subjective to everybody and what they have at their disposal, right? If you had $3,000 and you just let it sit in an account for 10 years, you automatically make $1,000.
It's a long time.
It is a long time.
These past 10 years, it felt like forever.
Yeah, without 3 grand. But if you take a look at it, so 3 grand made you 1 grand if
That
you
is
let it
true.
sit long enough.
Imagine what 100 grand would do.
Exactly. How about adding some zeros to it? So in 10 years, my initial investment will grow to 4045.05. And we are done.
Say,
We good?
Then we got the lecture questions.
Yeah, I think does everybody get example 6?
Yeah,
So I
that
don't
was
have to
pretty.
do the
That was
quick check.
pretty easy. Yeah.
Pretty easy.
That was
Okay.
literally so easy, which
All
is
right.
good.
That's what I like to hear. How about we just jump to the lecture questions so I can just let you guys go. Yeah. So I'm going to stay online. I'm going to let you guys work freely on them. If you guys got questions, let me know. How many people are online now? I never actually
You got
checked.
17.
Boom.
Everyone's muted though, or their camera is blocked.
Yeah.
They
And
don't
you
want
guys
to
can see you guys can still see my screen, right?
Let's check it out. Yes, we can.
Okay. 10:40. Okay. So at this point, I'm going to let you guys work on the lecture questions. If you guys need a break, this is actually good that we did this today to work out the last couple kinks because it seems like this is what we're going to be moving for or moving toward. Let me see. What do we have?
Professor Julio.
Yeah.
Due next week.
Say it again.
When is this due?
We'll do it a week from today. I need
Got
to
it.
move everything around.
Yeah, so when should we start sending you pictures of our lecture questions for the past few chapters?
I will start creating the links for them online.
So it's 3.6 and 3.7 we still have to send you, right?
Right. I'll make the links for those later on today.
Perfect.
So that people can take pictures of them to submit them online.
Sweet.
Got it.
Mohammed, you wanted me to still explain number 4 again? I'm sorry, I had the chat box closed. Okay. So for everybody else, let me actually do this really quick. I'm going to share my screen. Okay. Do you guys, I don't know if you guys get this thing. You guys see this thing up top?
I don't see shit.
So you can go into mute or into this thing. I think you can mute everybody except for certain people. So if you need some time to think on your own, go ahead and you can mute everybody else if you need to. And my tablet is going to run out of battery. So you guys can give me like 5 minutes to go downstairs, grab my stuff, and I'll be back. So I'm going to go offline. Well, not offline. I'm just going to take off my headphones. I'll be back. So don't fret.
We done?
I'm not sure. I think he's coming back, and then he's gonna like take. I think the exam is gonna be online. Yeah.
Fuck.
Nah, hey, nah.
This whole online stuff really changed the game. I have
I
never in my LMC career.
I know this is pretty cool, honestly. I could stay home.
It gives me a chance to catch up. I could say that much because, man, go actually physically getting up and going to class was a struggle itself.
I agree.
You can take a shit without missing class.
Huh.
I came in at take a shit without missing class.
That was perfect timing. You could
Yeah.
actually literally take a shit, and you could still like learn hypothetically if you wanted to.
So, okay, man, I'm serious though. I'm gonna consider this whole thing. I really want to go with you guys. Dana,
Yeah.
you guys are going all the way to Emmanuel, Joshua, just back with Dana, Cigar.
You want to sit? You can sit in the back of the trailer.
Where'd everybody go?
I'm still here.
Oh, people just went quiet. Okay.
Everyone went quiet.
Yeah. This is actually working out much better than I thought it would.
I think it actually, literally, like I feel like I'm still learning in class. It's just I'm on my computer because I feel like
Yeah,
we're all.
and this was on top of sort of messing around for the first maybe hour.
Yeah, honestly, I can only imagine how it's gonna run it once like you and the other teachers actually discuss how to use the program. I feel
Yeah,
like
so-
it'll like they'll actually like not mind it once they actually see it.
Yeah, and from what I've heard is that a lot of people are, because the college has given us a lot of leeway on how to go ahead and run all of this.
Yeah.
And some of this, a fair amount of the instructors are thinking of going what's called asynchronous, which basically means you're gonna have to do stuff on your own. And if you have problems or questions or concerns, those will be
Everybody
answered
still
through
seeing
email.
picture questions?
Huh?
There we go.
I had to.
Oh my.
If you have questions, Han and Chewy and 3PO, ask 3PO. He probably can do them faster.
Huh. So just for confirmation, so that on question 31, the 3.6 interest, wouldn't you'd move the decimal over, correct, to make it? Would it be zero? Would it be 0.36?
One more. Move it over one more.
0.036?
Exactly.
Okay.
I actually kind of like this. This is the new wave.
This is the new wave, huh? Okay, let me see.
And then semi-annually means, so would that be 2 then?
Only 2 times a year, right? Is our exam going to be online? I think so. I think it may have to be. I'll probably turn it into a take-home test, just so that you guys, yeah, so nobody can needs to come in and hand it in.
So when we actually do the work for that fraction, when it's like 1 plus 0.036 over 2.
Right, so just as it was in this one, right? You're essentially asking me what the heck I did with this piece. And it's going to erase half the equation, I bet you. Come on. There we go. See, told you. 0.03. So you're asking me what's going on with this thing right here. And that's how we got that thing.
Yes.
So you have to do the division, yep. And like I said, you know, if you give me 2 significant digits, that's all right.
So then 65.
In this case, right, you gave me, even if you get the 2 significant digits, like even if you round those, right, the rest of the process meant much more than how well you put stuff in a calculator.
So then if I did the math, would it be 1.018 if I,
and that's about,
if I
yep.
actually,
Yep. Okay, so I'm, oh no. My headphones are dying. Isn't that awesome? So let me answer this question really quick. So there was a request for me to do number 4 again by Mohammed. 5, 4. So to re-explain 4, so before we start 4, let me go back up a little bit. So if you don't need this, tune me out. If you do, tune in. This stuff in yellow right here. If you, so this is going to be part of the start exponentials is based off of this a times b to the x. The a being your initial value, right? And your b being the growth or decay, whichever one you have. So if you're growing, it's 1 plus whatever that percent change is. And if you're decaying, it's 1 minus that percent change, whatever that might be. Cool?
so when you actually, I'm so sorry to like cut into what you're saying. For
Yep.
that problem though, that was talking about the finance one, instead of it being 4, but the one on the lecture questions, that would be 2. You do 0.036 over 2, and then you add the 1, right?
Which one?
For number, let's see what
Is it
number
the
it
lecture
is
one?
here. For number 31 on the lecture questions.
Number 31 lecture.
Would you, so when you actually turn the percentage into a decimal, that's 3.6, it'd be 0.036 over 2, right?
Let me see. For wait, for which one? 6.
It was the third one on the lecture questions.
The car was valued at 38 grand.
Let me see. No, the one just above that, the one that's 31.
Oh, okay, yeah, the 3.6%.
Yeah, so that'd be 0.036 over 2, and you divide that to get, let's see here, to get
0.018, I think you said.
Yes, to get 0.0, yes, to get 0.018, and then you add the 1 to that to get 1.018, right?
Exactly.
Okay, perfect.
Got it?
Yeah, and then from there, you would take that number 20 and put it in the square root or next to the square root. So 2 parentheses 20, and then finish the parentheses off.
Say it again.
Correct. So when you actually do 31 for the last step, you do 6,500.
Give me a second. I can't hear you guys now.
No problem.
Still can't hear you guys. Still
Hello?
can't hear you guys.
Hello?
Let me see. Okay, I think, hold on. Something's trippy about my system. All right. Okay, can people hear me now?
Yes.
All right, okay. I had my headphones were dying. So note to self, charge headphones. So I had to jump over to my the microphone and the speakers for my tablet. So we're good.
I got the answer to 31.
All right. I would ask you to show me how you did it. How many? Let me ask you guys. Who here does have a tablet?
I do.
I do.
You do.
Mm-hmm.
Bryce, correct?
Yes.
And Edlin, okay. I wonder if I can allow you to show me.
To what?
To what? To show me what, like, I'm gonna test something out on you.
Okay.
Let's see if you can you request that let me see, advanced. I wonder if I can do it. No, I can't do it. Ha ha ha. Okay, let's do Joe. No way. You're moving stuff around.
I'm trying to write, but it won't. Like,
It won't
I'm clicking. Yeah.
I wonder if,
Clicking on your marker and it.
How about this? Click on this thing. Now try.
Yeah.
Oh, the galaxy marker. Try it out.
If I can just move the screen so it's centered, that'd be awesome.
Yeah, so I think if for those of you who have a tablet, you can request control of my screen and you can write stuff on here. And then equivalently, I think I can I erase?
You can't do it on a PC though?
I can't, so somebody scribbled a big, huge, like 8. That I can't erase.
Oh shit, that was me. I thought that was only on my screen.
Then
stop writing on the screen.
This is actually we're testing stuff out. We are testing stuff out.
See, if I would have known we had online school, I would have changed my whole life.
So, let's see. Is that you still, Joe?
Yeah, I'm just trying to use your marker. Oh, there we go.
So if you...
I agree. Speaking of which, do you think that this might open up the path to like more classes taken on like Zoom or like
Most
some format
definitely.
similar to
Most
this?
definitely, I think so. So,
Give me 5 minutes. Who's trying to get a text box?
you see that this option with the little finger with the little...
Yeah, I'm clicking it, but it's still a text box. Weird.
So then if you click this one, now try it. Wait, what? That one, now try it.
Okay.
So you see that little hand, the little pointer hand?
I take control.
It's not the very best thing,
No.
but it does something.
Sorry to cut you off from this problem, but for 44, would you plug that -3 in the X? So it'd be 2 parentheses 5 and then -3 on the top right.
Are you going to stick a seal for the month? Just curious.
You mean 64, right?
What was that?
For 64.
Oh no, for 44. So you would do 2. Obviously, the 5 is in the parentheses, and the X value would be -3, correct?
Yeah, I put the -3 in the X.
Yeah, so
That's what I thought too.
for some reason,
Man, the only bad thing about being quarantined is that all the Jehovah's Witnesses know you're home.
Oh my goodness gracious, y'all mess.
They're walking in a storm.
You know what? I don't think so. I think I'm gonna wait
There we go. So,
I just came back from LA last night. Everybody's scared to be around me.
oh my God.
I know you cough around like anywhere, everyone looks at you like you're fucking crazy.
You can't even breathe, and people are looking at you.
Yeah.
Pass the Rona.
As long as they don't cancel my flight to Miami for spring break, we're good.
Be the ticket's hella cheap too, huh?
I bought them literally like 2 weeks before all this stuff started going down.
I like tickets are super cheap right now. Like to go anywhere, it's crazy.
Right.
Gas is hella cheap too.
Yeah,
Yeah, I seen it too something some places. I was like, whoa.
maybe there's a silver lining to the economy slowing down.
So let me ask you guys, let me ask everybody this right now, and this is now me just testing stuff. Who's got a tablet with a stylus?
Hand down, man down.
I do.
No.
Dana, no?
No, I don't have it. No.
Darn it. Okay. Let me see.
No, I don't have one either.
Who was that? Oh, Brittany. Okay.
Yeah.
By stylus, do you mean like a pen?
Like a pen. Yeah.
I do.
You do? Were you just trying it when you were trying to write
Mm-hmm.
just now? Were you, was that you with the stylus?
Yeah, but it was kind of a weird angle. Try again, see if it's clear.
Yeah, let's try that again. This is me trying out stuff. Okay. Try to write stuff.
Try it a little slower.
Yeah. It doesn't completely register, does it?
Well, let me fold my laptop so it's actually.
Oh, I see. So you had it propped up.
Yeah. It just go kind of slow. No, hold on. I have buttons on my stylus too. I've never played with this before, so.
Yeah. You're my guinea pig in this case. I want to see how well it actually does, if it does good at all.
I mean, I could like do things. You want me to just like try and solve the problem on there for you and see how well it comes out?
Let's try that. Yeah.
Okay.
At this point, I'm just curious about what's going to happen.
5 years later.
Now, this is you being really, really, really gentle with it, isn't it?
Me just going very, very slow because it won't. If I go too fast, it just skips over it like I don't write anything.
Right.
That's kind of weird.
Yeah.
So how are we taking over your screen? So how are we doing that?
I gave Joe control.
Oh.
So there's an option for Zoom.
On your side.
On my side, where I can give you guys control of your guys. I can give you guys control of my screen. So technically, Joe right now is using my mouse, and yeah. Gave all the stuff. Yeah, don't bother with that one.
That's skipping a step or two, but
it's all there.
It works if you're on Zoom on your phone. All the controls for like writing, erasing.
Oh, really?
Well, I just made that pink mark across the screen.
How good was it?
Did you see that?
I did see it.
Okay, yeah, and then I erased it.
How exact was it?
What?
Was there?
Oh, how fast?
Was there a lot of lag? Little lag?
No, it was instant. I don't know. Do you want me to tell you when I do it right now?
Yeah.
Okay, hold
I
on.
know I saw you do a green one.
That was actually me. My bad.
Oh, that was you. Okay.
Okay, I'm gonna do it right now. Can you hear me?
Yep.
Oh shit! Didn't do it. There.
Whoa. And then you just erased it, right?
Yep, right now.
Okay. That's not bad. If
No.
you guys are on your cell phones, you can at least.
Hello?
Hello.
Oh, okay. I wasn't lighting up green.
If you guys do it on your cell phones, you can, instead of me saying, like, instead of me sort of like asking repeatedly, like, what are you talking about? You can just point it out.
Back up.
I'm taking a nap.
Let that boy take a nap.
It's too early to be taking naps.
I know.
I'm about to take a nap after this.
Oh, by the way, I just got a text message from my mom, and she's like, she was like, I'm passing down information. Within like 2 to 3 days, the president's gonna invoke something that's called the Stanford Act. And like, so basically the next 2 weeks, there's gonna be mandatory quarantine for the nation.
Really?
Yeah.
I'm going outside if I feel like it.
Wait, so we can't go outside at all?
I have no idea.
Or
This is just information from like my friend's mom that's in the military.
Oh damn.
Moving to Canada.
Okay.
So if you guys need to stock up on anything for the next 2 weeks, there you go.
Do it now, huh? Well, quarantine means just, I mean, it doesn't mean lock yourselves in your houses. It means just, I think it's stay away from other people.
Yeah.
So that means it means that you can still go on hikes, right? You can still be outside, but just don't be too close to other people.
Just give it to a minimum.
Yeah, keep that to a minimum. Nothing. No one wants cabin fever.
Yeah. I'm just passing out information too.
Okay.
As a heads up.
Hopefully that's hopefully it's not anything big. Interesting. Yeah. So Joe, you can still have control of my screen and I can still write over stuff.
Yeah, it says on the top of my screen that I still have control too.
And who was that? Oh, you, Joe.
Yeah.
Okay. Yeah.
Hello, Dad.
So I'll try to be better about writing stuff in a neat manner. Maybe we can use this thing where I give control to people so that
What?
so that I can so we can maybe incorporate some group work stuff in there. So
is all of this going to be recorded and saved like as we go along?
Yes. So right now I'm recording my end. I'm going to make a folder for it in your files on Canvas, and I'll start dropping them in there.
It's literally so cool, honestly. Like, we can go back and rewatch the lecture.
That's awesome.
Yeah.
Honestly, I really hope this does take off and like they actually like start making this a normal thing.
I hope so too.
A bunch of these teachers are going to come back from this break miserable.
That is for sure. That is for sure.
Are some of the older teachers who have been doing things like in class kind of struggling with like doing the alternative with this online?
I mean, this is something that people don't think, but it's very difficult to teach online.
I could bet, honestly, I could see why, because I feel like it's easier to interact with people in person
Right.
versus
I mean,
like trying to talk to them online, because you can, when you see them in person, you know if they're learning it or not, versus like people who have like their mics muted and their cameras, like you have no idea what's going through their minds.
right. And it takes different strategies to be able to transmit information that way, right? Like you wouldn't use something in the classroom that you would, like if you were to teach it in online, right?
Yeah.
Backwards, right? You wouldn't use stuff that you would regularly use online to do something in the classroom.
Yes.
The techniques and strategies that people use for either the class or online is going to be different, no matter what.
I think that there's a high chance that we'll stay online for the rest of the semester, or we're going back to class, or do you not really know or have a definitive answer?
I've been told for sure up to the 13th, we're going to be doing online stuff.
I really can't believe it. Has anything ever happened like this in history before?
In history, yes. In history, yes. The last time I think it happened worldwide was
SARS.
No, well, it didn't get as big. So yes, SARS did happen, but it didn't get as big. The last big one was in 1900 something, in the turn of the century.
The Spanish flu.
Spanish flu.
Oh, the early 1900s.
Mm-hmm.
Wow, that's crazy. But yeah, I feel like it's 2020, so like this whole like virtual thing, that's really gonna be like the transition eventually. Anyways, like most schools are gonna transition to online. I just watched an interview from Arizona State University, and you know they graduate a lot of people online, and like they're winning right now. Their rates are going up high, so people are trying to follow that.
Is that still a dog?
Oh yeah, my dog's laying on me.
Aw.
I was gonna say, who is snoring?
I keep forgetting that you guys can hear that.
I was like, dang, somebody's hungry.
Someone's stomach.
Yeah.
All bad.
Yeah. Dang. Okay. You guys got more questions about this stuff?
Yeah, so for
Yes.
for number 49, which is the second problem, the lecture questions, I wanted to ask you about whether I was doing this correctly or not. So what I did to start the problem out was I put in 4f parentheses 3. I put that 3 next to the square root 2. So it's 2 times 3. So it's 1.2e squared and then times 3 minus 0.3. I multiplied the 2 and the 3 to get 6, and then from there I got 484.11 minus 0.3.
Something went wrong. So your plugging in was right, but something went wrong when you finally plugged it in. So you should have something like, so just like you said, right? You're gonna have, I'm gonna write it down. Let me.
Oh, damn, Han's in there.
So 1.2 e to the 2 times 3 minus 0.3.
Oh, that's what, it's 0.3. Actually, I still have that. I'm okay. Actually, I'm okay.
So 2 times 3 is
6.
Right. So this might still be a problem for how you plug it in. So let me go to a calculator. It lets me. Yeah, my. Okay. So let me actually, so I'm gonna change the screen share so I can actually share you guys my screen. So if you guys have a calculator, like the one that you guys see on the screen, if you, so the E button is right there, right above the LN, right? So clear that. So if you want that E button, you have to do second.
Then press E.
Then press LN, and that'll get you your E. And now you put the 6. So actually, you weren't that far off, yeah. Oh, because he's okay. And then that times 1.2. And then that minus 0.3. Boom.
So I got 480, 484. Actually, so I actually did get that. I got 484.11455.219.
And then you need to do the minus 0.3.
Yes, and then I got 483.81.
Yep.
Oh, I just, for some reason the math came out. I don't know why that was so weird.
That I think is the same thing that I was saying. That's why I was like, something went wrong. But no, you were perfectly fine. I was incorrect.
Now for 44,
Mm-hmm.
did you get 2 over 125? I also got in decimal form, and I believe it was 0.016.
2 over 125 is correct.
Yes. Yeah, these aren't too bad. I think we should be okay with these.
Yeah, that's why I wanted to. 4.1 was the best thing for us to start working this thing out.
Yeah.
Does that make sense?
Yeah.
In terms of just one, starting a new section, right? 2, testing out all our stuff. Now I have to be conscious about cussing.
I feel like all my math skills have honestly been sharpened over the course of the past few months, or like the past few weeks we've been doing all this stuff.
Yeah.
So I haven't done a math class in like, honestly, it's probably been like since my junior year of high school, so it's been a long time.
Yeah. So let me switch back to this screen.
Wait, so how did you get the 480 for whatever it was for number 49? Like, how did you get the E?
The E, let me go back.
Mm-hmm.
So
second, and then what is it? It was on the left side, and you'll see E.
Yeah, so let me
Oh, you have to use the calculator.
Yes.
Yeah, that one you're gonna have to use a calculator for.
Okay.
And that's fine. I'm not gonna make a big deal about you guys using or not using calculators.
So when you use the calculator on that one, you would put in E6, correct? And then you would. So actually, what did you do? What was the whole process that you took to actually get that with the calculator?
So I just found out the E to the 6 part first. So second, so my E, see that blue E right
Yes.
there? Yeah, that's the thing you need. Since it's blue, we need to hit the blue button first and then hit my LN. Now it gave me, see how it gave me an exponential right there?
Yeah, you put the 6 up on top, right?
My 6.
And then you press enter, gives you the value, perfect. And then from there, then you would do times 1.2, correct?
Right.
And that'll give you your final answer. Okay,
Well, close. We still have to then, so once you do the 1.2 times the stuff, then minus the 0.3. But
oh yeah, the percentage or the yeah, and then bam, then you got 43.81.
Yep.
Bam. Okay, and then for Notice so for 64, all those ones below are all together, right?
All those 64. Yeah, so 64, try to do your best to find the, yeah, try your best.
Okay, so they actually have, they're all similar basically.
Yes. Oh, you mean these, right? The
Yeah,
two
so
banks,
so for the
the
function one, the function DH equals 50E. So for that one, is it similar to the ones we did above? Kind of like the one on 31 and 64? Those, or like the first one on 64? Do you do a
right.
similar thing?
Yeah, you are just plugging in the values for the function.
Okay, that seems simple enough. I got the first three. So those ones are, or I got 44, 49, and 31. 64 is the same thing as 31, I see. So that one's easy. And
Yep.
then those three additional ones they're kind of worded differently, but they are the same thing.
Mm-hmm.
Okay. Honestly, this chapter was not that bad at all. I feel like in the beginning I was a little confused, but now
Right.
that we went through the examples, it's pretty straightforward, honestly.
Yep.
That's why I got on the warm-ups or the lecture questions for the 3.6 and 3.7. I kind of forgot them. I had to refresh my mind by doing a few of the homework assignments. After that, it came back. That's what I kind of hate. I swear, like I take like what 3-4 days off, not like doing any math, which it's pretty rare. But I was just working over the weekend, but I forgot. I'm like I know all this. What is it? And then I went back and did like a refresher, and it was just like thank God.
Yeah.
Okay, let's see here.
I'm gonna play around with the background and see how. I'm not kidding. I had downloaded like a bunch of them.
Yeah, those are pretty cool. Got Chewy on this one, I see.
Yeah.
So where did you go to download them online?
I went online and just Googled them. I just said like enterprise.
And you had to save them into Zoom, or you save them on your computer?
On my computer.
Okay. So you went on Zoom. Okay. Because I found a web while you were.
While you were looking.
While I was learning, I was looking. So I said backdrop for Zoom.
Yeah.
Banner buzz or whatever.
Yeah. So the other one, let me see. I'm just gonna try another one. There we go. Now I'm on Hoth.
So for the lab hours, are you gonna like just go on Zoom kind of for that, and then we can just all join and talk to you about like certain homework problems or certain assignments?
That hasn't been decided yet from the department. My guess would be that this is my guess. I have a feeling that the lab hours are by and large going to just be put on hiatus for the semester, for the entire semester, which means my policy will have to be, and I'll give it to everybody equally. So if you were borderline and you did most of your lab hours, you automatically, well, that was the original that was on the syllabus. So at this point, if you are close to, I will have to give you the higher grade.
So I'm not close to it. Do I have any like? Is there any effect on me?
So if you are borderline, does that make sense? So that means basically, the grade breakdown that I gave at the very beginning of the semester.
Yes.
So it sort of each one of those. So before those borders for each one of the letter grades were fixed, right? Now they're going to be much more fluid.
Okay, so do we get marked down points for not finishing our math lab hours?
No, you will not get marked down at all.
Okay, for sure. Because honestly, I'm not gonna lie to you, I've honestly gone in there maybe twice, and I feel like I don't know. I feel like there's so many resources online. I feel like when I have struggled, you've always helped me out with the things I struggle with.
Yeah.
So I feel like for the most part, I got it. I feel like I'll go to the math lab once I really, really like know I can't do anything.
Right.
I know for Cal 1 and Cal 2, I'll probably be going in there. And actually, speaking of those, will you be teaching Cal 1 next semester?
I didn't request it. They didn't give it to me.
This is a sad day in the kingdom.
which would have been nice. I think that part of the plan is to do that eventually in for the math department.
Yeah.
If like if somebody teaches pre-cal, that they teach calculus the next semester and then so on and so forth. I don't know if that's gonna actually fly with the rest of the department, but we'll see.
That's honestly
Just to
so
let-
nice.
Just to let you know, D.Y. Ramos, he teaches Calc 1 and Calc 2. He's great.
And what's his name?
D.Y. Ramos.
Yeah. Mohammed asked a question about E having any special value. I did skip over that. So the definition of E is actually that thing right there. The definition of E, can everybody see? Yeah, okay. The definition of E is essentially this thing where the N value, where this N value right here, right there, grows without bound. So as N gets really, really, really big,
So for 64,
Mhm.
so would you be doing this, where is it? Would you be doing that AT equals P 1 plus R over N for that one?
Oh, no, not this one. Actually, you know what? I didn't show you guys how to do this one. So guess what that means?
You get to do it for us. Yes.
Or
we do it together. Well, that galaxy marker. Skip.
Are we skipping this problem?
we're gonna skip this problem. It's
All 64?
Thank God, I was gonna ask for help
yeah.
for this one.
We'll just go ahead.
What? All right. Honestly, I'm already done with the lecture. Then. Nice. With the lecture questions.
Yep.
Sweetness.
I didn't finish Mohammed's question. So does it have a special value? It does. E is approximately 2.718 to 8 dot 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 dot. E is essentially sort of like we haven't studied number yet, but maybe you guys have known of the number pi.
Yes.
Right? That it's a number that gets used so often, they gave it a symbol, the Greek letter pi, and the decimal numbers for it continue on without bound, right? E is essentially the same thing. So the beginning couple of numbers is 2.71828. And from there, it continues on to infinity. Like the decimal numbers keep going. It doesn't stop at all. And it happens so much in finance and in other applications of math that we just ended up giving it a nice symbol. In case it's the E. Yeah.
Didn't I tell y'all to stay out of my room? Oops, my bad, y'all.
It's okay.
I have a 2-year-old and a 3-year-old, and they
It
crazy.
was all to happen. And yeah. So is everybody done?
No.
Okay. You got maybe 20 more minutes? Okay. Yes.
I get everything for the most part. Would it be cool if I could lead the lecture?
Of course you can. You can leave whenever you need to.
Awesome. Thank you so much for the help. I will see you on Wednesday.
On Wednesday it is.
Later, guys. Have a good one.
We'll go
Bye.
on Wednesday.
And we can also email you to set up one-on-one meetings like this
That-
week, right?
So the primary duty of the math department today,
Mm-hmm.
figure out how that's going to work. So, like for example, right now, we don't know what to do with our lab hours. You guys need your lab hours. How are we going to figure that out? No clue yet. Does that make sense? More than likely, I think what's going to happen is I'm going to set up like a Zoom meeting and it's just one Zoom meeting that's going to be for my lab hours and another one that's going to be just for my office hours. And if you ever need to come and talk to me personally, right, then that's how we set up those. You would sign into just that Zoom meeting. It wouldn't be the one like right now for the class.
That would be awesome.
Does that make sense?
Yeah.
And then the same thing would happen, right? I would be able to share my screen and all that stuff and all that good jazz.
Yeah, because I need some special assistance.
Same.
That's okay. So I'm here just ready to answer questions.
I have a question on 31. So
31.
yeah, I'm like mostly kind of done with it. I got to the point where I did 6,500 times 0.018 and then put that in parentheses and then put the 40 after that. But I don't know if I did that right.
Okay, so let me actually write that out. So for the equation, turn off the video. Well, I need to turn off the camera. Okay, so did you get this equation, the one that Joe wrote out?
Yes.
Okay.
Wait.
So then,
Yeah.
so then A of t, let me write it a little neater. 6500 1.0 to the 2t.
Mm-hmm.
Okay. So your question is, how do you plug in the 20?
Yeah, do you put it into T?
Right. So the 20 years, right? The t was the 20 years.
So then it would be 40?
Exactly.
Okay, so then would I distribute the 40 to the 6,500 and then the 0.018 and then
So that's a good question. Let me roll it up really quick. 2t. Does it hit the 6,500?
No.
It does not.
No, yeah.
So that the 2t, which in essence is your 40, correct?
Mm-hmm.
That 40 should only be hitting that thing, the 1.018.
Oh, so then I would just do 40 times 1.018 and then whatever that answer is multiplied by 6,500.
Not times to the power of. So make sure you do it to the exponent. But yes.
Oh, so it'd be 1.018 to the power of 40.
Exactly.
Okay, how do I do that? I have to get I can't do that on my phone, huh?
You can. It depends on what phone you have, though. So let me turn on my camera again. I always do. Let me turn on my calculator. Oh. Now it doesn't even want to show. Yeah, it doesn't show my thing yet. Virtual background. There we go. I need to turn off my virtual background. There we go. So see,
Oh wait, hold on.
Classroom where you guys would be.
What? That's trippy.
Yeah. So, okay. Phone. So this is my cell phone, right?
Mm-hmm.
Actually, I should rotate the, let me, give me a second. It's, yeah, enable mirror effect. There we go. Oh, whoops. No, that's it. Okay. So now this is my cell phone. That's
Mm-hmm.
it's all funky. If you look at, so over here, I have an option that pulls this right here. You guys see that? The little caret that points upward?
Yeah.
That is the exponent. So if I want to do the 1.018 to the 40, and it gives me my answer.
Oh, okay. Let's see if mine
it?
has that.
Yeah. If not, I mean, I think some of the iPhones, you won't get this little blue bar that pops out like here.
Yeah, I
right
don't think I have that.
Turn it sideways and it'll pop it out.
It didn't work for mine, but I'm on my iPad, and I'm also not even using an iPhone calculator app. So I feel like if I just use the iPhone calculator app, it'll be fine.
Yeah. Any which ones you guys want to use. I leave it up to what you guys feel comfortable with.
Okay.
All right.
Okay, so I also had a question on the one for the function d8 equals 50e minus 6h. You know that one? What is my question? Where would I plug in the 6 when it's, because it wants us to plug in the 6 hours? Where would I plug that in? And would I plug that in for minutes? So would it be 360, or would I plug it in for hours?
You would want to do 360.
Okay, so then I would do 50e minus 2 times, oh wait, that's a 0.6. Oh, okay, hold on, times 360, and then I would have to put that to the 50 as an exponent.
So that the exponent is just that negative 0.6 to the 8, or so the exponent is just this thing right here.
Wait. Yeah.
Does that make sense?
Yeah, so I would, oh wait, so I put that to the 50 after I did the negative 0.6 times 360.
The 50 is being multiplied here, so there's a multiplication in between there. So the only thing that needs to go,
so it's actually to the e that's doing that.
Exactly. So you need e to the.
How do I find e?
So that was the thing that was on your calculator.
That's what I was thinking.
So if you, let me see. Yeah. So let me switch my screen again. It doesn't do it. Okay. Let me, you're trying to be all cool and stuff, but the virtual background's not working. There we go. So same thing. So for me, it has that little bar.
Mm-hmm.
It has the value right there. So e to the. Like I said, for phones, if you need to rotate, if you rotate it, it sometimes gives you sort of some advanced buttons that you can use.
Okay.
Got it?
Yeah.
Make fun. I heard somebody put something in a microwave.
It was me. I need coffee.
I'm so hungry.
In a microwave?
I had to reheat it. I left it.
Yeah.
People put coffee in the microwave all the time.
So, yeah. Edlin asked me a question. You do need to convert it to minutes. So I think that's what Bryce just asked.
That is what I just asked.
Yep. Well, all right. I mean, it was semi-slow, but we semi got through it.
Did anyone get E for that one?
For which one?
The bloodstream one.
You're not supposed to get E.
Oh, really?
Yeah. Try plugging it in again on your calculator.
Because every time I plug it in, like I put E, or no, I did, what did I do? I did, 360 times, negative 0.6. Let's see. What was that? Which is 216. So then I did 216, E of 216, and that got me 2.718.
Somebody told me that they just got an error. Let me double check it really quick.
Wait, how did you solve for the 6 hours?
Negative 0.6 times 6 hours, so 6 times 6360. Equal to that. E to the. I'm checking. Oh, you know what? God dang it. What am I doing? Okay. Guess what?
It's a skip?
No, it's not. I think I miswrote it. So instead of minutes, put in hours.
Oh, okay, so we don't have to do the 360.
Yeah, you don't have to do the 360. I think that was my bad. The variable itself was H, which is supposed to be hours.
That's what I was thinking. I saw that. I was like, he must have did a typo.
That is a big, huge, fat freaking typo. That's my bad.
Let's see. Also, then, it would be negative 3.6 E, or E of negative 3.6 or whatever.
Say it again?
Would it be negative 3.6 E or E of negative 3.6 or whatever?
Right, it's going to be E to the negative 3.6 in that case.
Okay. So how would I and we don't solve for E. We don't have to figure out what E is.
Well, no. So even like if you don't even have the value or the button for E specifically on your calculator, if you just go ahead and put in 2.71828 as an approximation, that's fine.
Okay. Oh yeah, because that's what E is. Okay, that makes sense.
Wait, because the exponent is a negative, do we turn it into a fraction?
You can.
Should we do it in this problem though?
If you
Or-
want.
Man.
So I know. If you want to do it as a fraction and then plug that fraction into your calculator, that's fine. If you just want to plug in negative 3.6 into your calculator, that should also be fine.
All right.
So long as you show me the math for it, you're all right.
All right, thank you.
Mm-hmm. So what are you guys thinking? Good, bad?
It's good. I understand it.
Okay.
I think.
Yeah. In terms of the format, people happy with it?
Yeah. It doesn't take too much brain power for me to do it.
Well, that's
It's
good.
not a whole lot of steps. That's the good thing.
Yeah.
I'm saying like the Zoom meeting and all that stuff. Everybody's
Oh,
Yeah. Yeah,
I like
everything
log
was
in,
like
Zoom.
straightforward.
Yeah. All right. This sounds good. Is somebody outside?
Do you hear a bird?
Yep.
Oh, I have a bird in my house.
Oh, okay. My parents have little parakeets, some quails, some.
I have a parakeet.
You have one parrot? My parents have, I want to say like 10, 12 of them.
I bet it's so lively in that house.
My parents say they like waking up to them chirping. I'm like, okay.
I get so annoyed. Although I sleep until like noon, so.
Yeah. Yeah. Yay, it works.
Okay, I think I'm gonna go now, but
Yeah, me too. I think
I'll be checking back in with you very soon.
Yep, we'll figure out what's going to happen with the rest of the course itself. Once I have answers, you guys just check your emails.
Okay.
Cool?
Yep.
Okay. So I'm going to stop the recording here, and I shall sign off. Brittany, and actually, let's wait for that.
Okay, so I emailed you. Can you hear me?
Yep.
I emailed you quite frequently. Maybe like
On my, did you send it to my actual email or did you send it to Canvas?
I sent it to Canvas.
Canvas. Okay. Let me check in Canvas.
Okay. But basically I'm going back and doing all the assignments, but now it's only allowing me to view them instead of actually do them and turn them in for credit. I thought maybe it was because I was out of late passes, but I don't even know. So
No,
say
I
something.
think I might know the answer to.
But it was even like things that were only a day old from like turning in, it still wouldn't let me do them.
Oh, okay.
The further back you go, the more late passes it takes from you still.
Right. That's not my intention. I think I've already repeated that a bunch of times.
Yeah.
But I think I know what that problem is, the one that you're speaking about.
Okay.
Let me go to my open math. And this is the stuff for chapter 4, correct?
No, it's late assignments.
Late assignments. Okay, hold on.
Mhm. Like the actual assignments, and I think I just have like 2 video assignments I didn't do.
Yeah. Okay, hold on. Let me see something. Okay.
Hey, Julio, could you help me out with 64?
Yeah. Let me.
Um,
Okay, go ahead.
Yeah, just I'm not sure what to do here. Like, I thought we were, at first I kind of thought that we were gonna do it like, oh,
Yeah.
said, oh,
Skip it. I didn't give you guys an example for it.
oh, okay, all right.
Yeah. My bad.
Oh, it's cool. I was just on autopilot. I saved that one for last, so I didn't get it.
Yeah, I know.
All right, I guess I'm done.
Then you're done.
So how do we turn it in? Do we just take a picture and?
Yeah, so I haven't set it up yet. I haven't gotten that far in for you guys. But I'm going to start setting up the lecture questions so that you can submit them through Canvas, and a picture would be fine.
All right.
So yeah, once I do, I'll send everybody an email.
All right, thank you.
Cool.
Well, I guess I'm out of here.
All right. I shall see you Wednesday. Okay, so Brittany?
Yeah.
I think I'm gonna need to go into my office to change them all because I think I know what's here. Let me just do this. Which one are you looking at in particular?
Oh man. I know I don't think I could turn in, was it like 2.3 or something like that? God,
Okay.
I'm awful.
No, that's fine. Which one, the video lesson or the video assignment?
The assignment.
Oh, the actual assignment, okay.
Yeah, the actual assignment. That was, yeah, because I was done with all the videos. I think except for like 2 and 4 or something, wouldn't allow me to do it.
Okay, so never mind. I think I need to do it through 2.3 you said, right?
Yeah.
Okay, let's see. Not letting you see it?
No, it's letting me see it, but it says this is in view mode only. Answers will not be saved or submitted for grade or something. I'm pulling it up right now.
It's not allowing you to do, is there no option for you to,
like take it?
yeah, to use a late pass on it?
So it says in review mode, no scores will be saved. And I can't do anything. And that's even 3.4 graphs of polynomial functions.
Okay, so that may be.
That's why I thought I was out of late passes. I was like, because.
No, I mean, I've already doled out like 150 of them collectively.
Oh.
Not be anywhere close to using them all up.
Okay.
Or actually, maybe you might be, but like I said, that's not my intention. Let me see. So 2.3, not letting you do.
I think it goes all the way back to. Let me see which ones I've actually done. Because I had to stop doing them because I realized I was halfway through with one. I was like, oh, answers will not be saved. I was like, wait, why?
Right.
So 1.6, 2.1, but 1.6 is the oldest one that I couldn't do because of that. And then the newest one I couldn't do was 3.7.
And there's no option for you to do it by late pass?
No option. Everything says in review mode in like bright red, bold red.
Okay, what about this?
Yeah, 3.8 is the last video assignment I didn't complete, and it says in review mode, no scores will be saved. And it says create new version of all questions. And when I do that, it says still in review mode. And it says view your scored assessment. all I can do there is show last attempts, show review attempts, and it's nothing. It's like I didn't even answer any of these.
Yeah. Keep open for ungraded. No, but then I don't want to keep it open. No, I do want to keep it open. Okay, you might need to let me sit on this one for a little while because it's not giving me anything for why that's happening.
Yeah, at first I thought it was because like 1.6 I had open and like left it on my laptop with intentions of doing it that day.
Right?
And then the next day when I reopened it, it said the same thing. So I went to a different assignment, but then everything started to say that. And I was like, okay, well, let me go to 3.8. And then like if it was already past the due date, it would say in review mode instead of like use late pass.
Yeah. So how about this? Do you mind showing me your screen?
I'm on my laptop while being on my phone with you.
Oh. Are you?
So I can do that. How do I share my screen?
You know that drop down menu that pops up?
Drop down menu that pops up. Oh yeah.
There should be
share
a button
content.
Huh?
Share content.
Yeah, share content. Let's see what happens.
Let me pull it up. I'll go to.
It'll ask you if you want to specifically share just your browser, then it'll just pull up the browser.
Okay. Let's see. What the hell? Launch external tool. Okay, let me try to share it. Share content. You cannot start screen share while the other participants are sharing.
Okay, let me. So it's not letting you share anything, huh?
Yeah, maybe if you turn off your screen, is that wrong? Oh, you did, huh?
Well, how about this? Yeah.
No.
There, I turned it off.
You cannot start screen share while the other participants, yeah. I don't know.
Participants or what?
While the other participant is sharing.
Okay, let's see.
The host has asked you to start your video. Okay.
Let's see if that works. So then now, because I think I saw you on video earlier.
In a meeting.
Yeah.
And I was all, heck no.
So you, can you still not share? Brittany?
No.
No.
Not share.
Still not sharing. I'll have to ask around then, because nothing on my end. See your questions.
Yeah.
Nothing on my end is.
Can you hear me?
Yeah, I can hear you. I think you might need to turn off your video. Let me stop your video. There we go. Brittany?
Yes.
Oh, okay.
Can you hear me?
Yeah, I'm going to need to ask around because nothing that I see here is keeping you from trying more of it out.
Mm-hmm.
Does that make sense? So
Yeah.
the due date is set for, let's say for 2/3, right? That due date was set on 2/17, so February 17th.
Mm-hmm.
And I have a check here for keep open for ungraded
Open.
practice after due date, but that doesn't do
Uh-huh.
anything. Like,
Yeah, it says allow access right there too. That's why I thought for sure I had ran out of the like
late
late
passes.
passes because at the time I was still like when I was doing everything. Yeah, I was still
Maybe-
being charged. Well, charged, okay, quote unquote, like
Yeah.
7 at a time, 8 at a time because my assignments were so old.
Let's see if you actually ran out. Brittany, no, you still have 50.
Oh wow.
I'm gonna change this.
Why do I only have 50?
I don't know.
Everyone's over in the hundreds. I was all, hey.
Yeah, everybody's still in the 100. Well, a couple people. There's one person that has 40,
Man.
but everybody else is still in the 50s. So, and I mean, I'm doling them out like candy at this point.
Yeah, I know.
Because I don't understand why there's still.
Get your late passes.
Yeah. This
Like
isn't.
Oprah, you get a late pass. You get a late
You
pass.
get a late pass. You get a. I don't know why it's I'll ask around.
Okay.
Now, keep go back and look at it every couple days.
Okay.
If you're able to do it, but for now, just don't really worry about it too much.
Okay.
Just keep on with the stuff, the current stuff.
The current stuff. Got it. No problem.
Okay.
All right. See you Wednesday.
See you Wednesday.
Bye.
Bye. Okay. I'll see everybody on Wednesday.